I hope you're having a great day and ready to start doing some math. Today we're going to take all of our little pieces we've been working on for the past week and a half and put them all together to try to determine if our shapes are similar, and in just a few minutes move into finding missing side links to different polygons. What we're going to do, first of all, we need to make sure that our two polygons are in the same position, which they are. So sometimes I just highlight it because it makes it easier to see. And I'm going to set up two proportions just like we've been doing for a couple weeks now. This is the top and then the side, or you might say the length and the width. We want to make sure that we set these up in the same position. Remember we talked about corresponding parts. So this piece, the 8, and then 10 here. So then this one must be 4/5. The key is to always keep everything consistent. And are they similar? We talked about for probably about 2 weeks now. Just multiply these diagonals. It will be the quickest way to tell if they're equal or not. And that gives us 40, and that gives us 40. So that would be, yes, these two shapes are indeed similar. So let's try a couple more of those. If I look, I've got the shapes are in the same position. So now, again, the key is to keep everything consistent. So the left side, if I put 18/49, then I have to do 90/245. Now, it would be okay to do 49/18. So if I did 49/18, then on this side I would have to come over and do 245/90. It doesn't matter as long as it's consistent. That is the key, to keep it consistent and to put our corresponding parts in the same position. So if I do 18 times 245, I get a big number, 4410. And then if I do 90 times 49, I get 4410. So then my answer would be, yes, they are similar. I could come over here and check this one if you wanted to. It's the same numbers. Let's see, 49 times 245. Why did I do that? I don't know. 49 times 90. I wasn't paying very good attention. I apologize. 49 times 90, which again is 4410, and then 18 times 45. Gracious, I'm struggling today, aren't I? 18 times 245. Maybe I need to start over. Okay, so again, you got the same thing going on in both of those, so it doesn't matter. The key is keep it consistent. All right, again, if it helps you to highlight or draw, we've got, I'm going to say, the roof of the house and the side of the house. So 4.5 times 8.6 and 54 and 103.2. And we want to know if they're similar or not. So 4.5 times 103.2. And I get 464.4, and then try the other side, 8.6 times 54, and I get 864.4. So, gracious, I am struggling today. 864.4. So then this one would be similar also. So now I'm going to sketch out another one real quickly. If I wanted to check these two, if I do 10/8 and 14/16. Remember, I kept it consistent, so the left and the bottom, the left and the bottom. So that's going to give me 160, 10 times 16, and then 8 times 14. So then for that particular problem, it would be no, they are not equal. So that's just getting us warmed up to get started to find numbers that are missing. And this video may get kind of lengthy. I'm going to apologize ahead of time if it does. If I look at numbers that are in the same position as our shapes are facing the same way, you notice this time I have an X in there. So if I set this up 3 over 4 like I just did, and I want it to be equal to 6 over X, which you may be able to look at that and do scale factor like we did the first week of school and tell what it is. But let's go ahead and solve it just in case we can, or just so we can practice for those problems that are more difficult. So if I look at my diagonals again, remember I told you I always like to start wherever my variable is. So 3x equals 24. So if it's 3 times x, the opposite of multiplying is dividing. And we're going to divide both sides by 3. So then x equals 24 divided by 3, which is going to give us 8. So if I wanted to check it, I would put 8 in this position, and I would do 24 times 8. Gracious. 3 times 8, which is 24, and 6 times 4, which is 24. So I know I got it right. So that means that this missing piece has to be 8. Okay, let's try another one. And we're going to do several of these. If I look at this one, if I put 15 over x, then I would need to do 20 over 12. Keep everything consistent. So if I multiply my diagonals, I like to start wherever my variable is. So I do 20x equals, and then if I have 15 times 12, 180, and I'm going to divide both sides by 20. You can probably do that in your head. It is 9. So that means that this value has to be 9. And if I wanted to check it, I could put a 9 here and do 15 times 12, which we already know is 180. And we can double check that 20 times 19 gives us that 180 also, and it does, so we know we got it correct. So the nice thing is we can always check these, so we should know how we did on them. Now if you look at this one, you should notice that the shapes are not facing the same way. So what I like to do is redraw them. So if we notice we got the long part at the bottom and then the smaller on top. So if I kind of do a sketch, the longer side is x, and then this piece is 18. So now it's a little bit easier to match up what's going on in the two shapes. So I'm going to slide this over a little bit. So if I do 12 over 14, then this has to be 18 over x. I like to start wherever my variable is, so that's going to be 12x equals, and I don't have enough room to show you everything I want to show you. And then if I do 14 times 18, so 14 times 18, 252. So now all that's left to do is divide by 12, and x equals 21. So if I go back and put my 21 here, then I can always go back and double check and make sure that it is right. So we're going to keep progressing and get a little bit harder each time. I look at this one, it tells me that the triangles are similar and it wants me to find x. Well, these all look a little bit crazy to me, so I would well, what I would do is redraw both triangles. And I see that I have one arc and then I have two arcs. So between my one arc and two arc is a 70. So let's look at the big one. We got a one arc and two arcs, and that is an X. So we want to try to number this the same. So the side with the two arcs, is a 120. And then the side with the two arcs over here is 240. So now I've got them set up the same way, so it's going to be easier to set up our proportion. To me, I would get the numbers backwards looking at it that way, so I always like to redraw it. It doesn't take but a second, and it helps ensure that we get it right. So 120 over 70 and 240 over X. I'm going to go straight to my variable. So we get 120x and then 70 times 240. It's no harder. I'm just going to have bigger numbers. So 120 times 240 gives me 28,800. And then divide by 120. And x equals 240. Now when I get that, something just doesn't seem right to me when I look at that. Because if I think about the scale factor is 2. Some of you may have already recognized that if I say 120 times 2, I'm going to get 240. So then 70 times 2 should give me 140. And I came up with 240. So I must have done something wrong. So let's go back and see if we can figure out, or you may have already noticed what I did wrong. So we got 120x. Let me go back and do 70 times 240. Okay, so there's my problem right there. So this number should have been 16800. And then divide that by 120, and I get 140. Had I gone all the way through this problem, if I had to put 240 here, then when I cross multiplied, I would have got two different numbers, and that would let me know that, yes, Ms. Garris, you did indeed mess up. But we noticed it before we got to that point. So I would definitely double check this one. We kind of already double checked it when we were looking at scale factor a second ago and said it didn't look right. But 120 times 140, that gives me 16,800. And then let's make sure this diagonal gives us the same thing. So 240 times 70 equals 16,800. So now I got it right. All right. We got two more problems. I know this is probably the longest video we've had so far. But it asks us to estimate the height of her school's gym, Now we've got Nicole, and it says that she is at the top of the gym. Let me start over. Gracious, I'm struggling today. To estimate the height of her school's gym, Nicole sights the top of the gym wall in a mirror that she has placed on the ground. The mirror is 3.6 meters from the base of the gym wall. Nicole is standing 0.5 meters from the mirror, and her height is about 1.8 meters. What is the height of the gym wall? Well, the nice thing is they've put all those measurements in there for us. We could have sketched it all out ourselves, but they sketched it for us. But when I look at that sketch, the triangles are facing two different ways. So we need the tall part and then the shorter part. So it said, here's the gym, and that's what we're looking for. What is the height of that gym wall? That's what we don't know, so that's going to be our X. And it says that she's standing 3.6 from it, and then we need to draw Nicole. And Nicole is going to be, we've got 0.5, and then